Hey guys, we're doing our 4-4 notes, and this is on periodic functions. So periodic functions are functions that happen over a period and then repeat. So here's our sort of formal definition. A function is periodic if there's a positive number p called a period of f, such that if I were to add the period to whatever input I'm looking for, I'm going to get that same input. So again, this sort of happens over a cycle where the behavior repeats. So one way to picture it is sort of like temperature over time, where, a certain period, so throughout the year, the temperature is going to go up, come back down. So let's say this is like the spring, it goes up over the summer, comes down in the fall, down in the winter, warms up in the spring, and that behavior repeats. Okay, so that would be an example of a real life periodic function. The smallest period of a periodic function, so to get from where that period begins to where it ends, and it can't be subdivided any further, that's called the fundamental period of the function. So in other words, from here to here, let's say, this is like 12, the period of this function would be 12, because as soon as we get to 12, that behavior repeats again, and we get another period. So what we're going to do for model 1 is I'm going to find the fundamental period, and then I'm going to calculate what f of 99 is. So how to do this, I'm not actually going to graph out that far. I'm just going to look at where the behavior repeats and work from there. So here the fundamental period of f is, I'm just going to sort of look at where this behavior starts. So here, if I kind of use the origin as an anchor point, and I look at the function increasing, decreasing, decreasing, increasing, and then landing back where y is 0, that interval there gives me a full fundamental period. So if I use my numbers here, the period is 4. Okay, and then to find f of 99, I want to think about how many 4s, how many repeats of 4 are going to fit in that 99. So I like to sort of think about, if I were to divide 99 by 4, what would I get, right? So I would get 2, 6, 26. So 9 goes into 4 twice with the remainder of 1. 4, sorry, that's 24, not 26. Try that again. 4 goes into 19 4 times with a remainder of 3. Sorry, to fix that camera. So another way to think about f of 99 is think about it as f of 24 times 4 plus 3. So that's just a repeat of the period. So it's essentially going to be the same as f of 3. So f of 99 and f of 3 are going to be the same output, or the same value. So if I look at my graph, f of 3 is -2. So f of 99 is also going to be -2. So now you're going to do the U-try. Don't forget, I have photos of this whole packet in Google Classroom, so you should do the U-try, then you should pause and look at the photo and make sure that your work matches. So I probably should have mentioned that on that last problem, we don't actually have to find the amplitude yet. But you will be finding it here, and actually that question is a repeat right here. So if a periodic function has a maximum value, capital M, and a minimum value, lowercase m, then the amplitude of the function is the average. So amplitude is sort of like, if you think about a function that looks like this, and we want to sort of figure out what's the amplitude, we want to think about where's the mid-range of that function and what's that height there, right? So the way we find that algebraically is we find the max, we find the min, and we average them. So we'll divide by 2. So this here, this minus the minimum, that's important because if we're subtracting the minimum, we have to find like the total difference between the two. So here for my model 1, my maximum was a 1, my minimum was a 0. So my amplitude is 1 minus 0 over 2, which is 1/2. So 1/2 is my amplitude. And again, you're going to find your amplitude. So you can pause the video here, you try number 2, and then we'll move on to this next part. So you probably remember from Algebra 1 a little bit, probably mostly in Algebra 2, that we can apply vertical stretches and shrinks to functions. So if we think about this one here, this periodic function here as sort of our original function f of x, right? This function represents a vertical stretch. And this function here represents a vertical shrink. So you'll notice that our x-intercepts are maintained, but these relative max and min points have either been stretched away from the x-axis or pushed closer to the x-axis. That happens when we have some constant that we are multiplying our function to, our output to, okay? And when that constant is greater than 1, it's going to be a vertical stretch, like this. When that constant is positive but less than 1, so like 1/2 or 2/3 or 5/6, that is going to be a vertical shrink, such as this one here, okay? As it turns out, that interpretation changes a little bit when we're looking at horizontal stretches and shrinks. So if we look here, and I want to sort of think about this as being my midline f of x, I would interpret this one here where everything's been a little bit narrower, okay? That is going to be a horizontal shrink because my values have been pushed closer. And then this guy here with this curve that's much, appears to be much wider, that's going to be a horizontal stretch because individual points have stretched further away from each other. And when our C value, so if I sort of think about it like I'm multiplying my input by some C value, when it's greater than 1, that's actually going to result in a horizontal shrink. And when it's less than 1 but still non-negative, so like 1/2 or 2/3, that's going to represent a horizontal stretch. So these ones aren't quite as intuitive. And in a lot of cases, we're going to be able to sort of manipulate these, not always with periodic functions, but with other functions that we've graphed, like absolute value functions or quadratic functions. And then down here, we just have a little explanation of where those C values go to represent the stretches and shrinks and how that modifies the period of the given function or the amplitude of the given function, okay? So we want to sort of recognize that vertical stretches and shrinks sort of pull from some baseline, whereas horizontal sort of push or pull along the other axis. So it really changes the behavior of the graph and where our amplitude is affected versus where our period is affected. So here, amplitude affected, not period. Here, period affected, not amplitude.